now we're talking about converting rectangular equations into polar equations. Just like before, we want to recall the concepts of rectangular and polar and how they're related. So you know that x squared plus y squared equals r squared. You know x equals r cosine theta and y equals r sine theta. Then we have the tangent of theta equals y over x. And then this one, which might come in handy every once in a while, sine squared plus cosine squared is 1. Similar to how we converted polar equations, we are just going to substitute in things where it's necessary. So for the first example, convert x equals 1 into a polar equation. We know that x equals r cosine theta, so simply replace x with r cosine theta. The goal for all of these is to get r by itself. R is kind of like your y. Usually you want y by itself. This time you want to get r by itself. So you would then isolate the r by dividing by cosine. And then you should remember that 1 over cosine is secant. So you could say r equals -1 times secant or just negative secant. Now let's do the next one. Convert x squared plus y squared equals 9 into a polar function. Now, you could plug in r cosine theta and r sine theta in for x and y, and you would eventually get the same answer. But we want to operate on efficiency here. So x squared plus y squared is r squared. So x squared plus y squared is r squared. Square root both sides of the equation. R equals 3. You could also say r equals -3. It's technically the same thing because it's just a ring around, or it's just a circle on radius 3. So you don't really have to say both. Just one will suffice. This one gets a little bit more fancy. We have, let's keep these in mind. So we have x equals r cosine theta. So I'm going to replace x with r cosine theta. And then y is r sine. When you square this, make sure you square both the r and the sine. Again, the goal is to isolate r. There's a lot of different ways you can do that. You only really want one r. There's only a few cases when you can have an r squared. So I'm going to divide by one of the r's over here and the sine. That will make the extra r cancel out. And so now, on the left, I'm left with cosine of theta over sine squared theta equals r, because that r canceled that one out. And now I only have one r. Now you could stop here. Typically, we like to see this written without division if we can. So if we break up the sine, cosine over sine is cotangent, and then 1 over sine is cosecant. So this would be considered your totally simplified form, but this is also correct. Now this last one, pay close attention, because you're going to do some manipulating with the x's and y's part of this first before you substitute your sines and cosines. It's going to make life easier for you. So first, go ahead and multiply this out. So this would be x squared plus 2x plus 2x plus 4. And then we have x squared plus 4x plus 4. And then the y squared doesn't change, and neither did the 4. Then go ahead and combine like terms. The 4's will end up just kind of canceling each other. And so we have x squared plus 4x plus y squared equals 0. Now, we have less things to deal with. So when we substitute in our cosine of theta for x and our r sine theta for y, we're going to have less things that we have to deal with. But even more so, remember that x squared plus y squared equals r squared. So notice you have an x squared and a y squared. So that together makes r squared. You could replace them with sine and cosine and eventually get to the same answer, but it's a lot more work. And then we have plus 4 times, that's an x, so that's r cosine theta. So now this problem is a little bit strange. It is equal to 0, so we can factor it and kind of think about that. When we factor it, we factor out the GCF of r. So we have r equals 0, and then r plus 4 cosine theta equals 0. Now r equals 0 is just a point. It's literally the point in the center because it's a circle with a radius of 0. So we don't really think about that as an equation. I mean, it is an equation, but that's not really what we're going for here. We're going for a slightly more complicated equation like this one. This one you can isolate the r and get negative 4 cosine 0. And that's your answer. So my tip to you here is in these more complicated problems like this example, go ahead and try to FOIL things out before you substitute. A lot of times it makes life easier on you. That's all I have for you. Feel free to email me any questions, and as always, make good choices.